All right, let's dive in. Today, we're looking at a truly elegant model that has brought order to complex software projects for decades, the 4+1 view model. It was designed to answer one really fundamental question, right? This is the central problem every large-scale software project has to deal with. I mean, you've got dozens, sometimes hundreds of people all working on the same system. How in the world do you keep everyone on the same page and stop it all from collapsing into a tangled mess? It's a huge challenge. And the answer, it turns out, is having a structured approach. So the root of the problem is this. Every project has a ton of different voices, or what we call stakeholders. And the thing is, each one sees the project through a completely different lens. It's kind of like that old story about the blind men describing an elephant. You've got the developer who's totally focused on the building blocks, the classes, the code modules. Then there's the system administrator, and they're just thinking about the hardware and the network it's going to run on. Meanwhile, the project manager is worried about organizing all the work, and the end user, they just want to know what it does for them. All of these perspectives are totally valid, but they're also incomplete. And this is exactly where communication just falls apart. So, how do you solve this communication puzzle? Well, you create a master blueprint, one that can be read and understood by everyone involved, no matter their role. And this is precisely what the 4+1 view model gives us. It's the elegant answer to all this potential chaos. Now, the key thing to get here is that the 4+1 view model isn't just one giant, complicated diagram. It's actually a framework for creating multiple simultaneous views of the exact same system. Each view is a representation tailored to a specific set of concerns. This way, every single stakeholder gets the information they need in a language they can actually understand. Okay, let's break down the 4 and 4+1. We're about to explore the 4 main views of the system. I want you to think of them as different pages in that master architectural blueprint we were just talking about. First up, we have the logical view. This is all about the what. What is the system's function? What does it actually provide to the people who are going to use it? It answers this simple question: what services is this thing going to offer? This view is made, first and foremost, for the end user. It spells out all the functional requirements, the services the system offers. The blueprint analogy here is just perfect. This is like the client's floor plan. It shows you the rooms, the layout, the spaces, but it doesn't get into the nitty-gritty of the plumbing or the electrical wiring. Next up in our blueprint is the process view. Here, we shift our focus from what the system does to how it actually runs and performs, especially when it's under pressure. This view is absolutely crucial for system integrators. It tackles all those non-functional requirements, things like performance, scalability, and how different processes talk to each other. Sticking with our building analogy, this is like the plan for the HVAC system and the elevators. It's not about the rooms themselves, but about the flow and the systems that make the building usable and efficient. And now we get to the perspective of the people who are actually in the trenches building the thing. This is the development view. This is the world of the programmers and their managers. It shows how the software is broken down into modules, packages, and subsystems. In our analogy, this is the contractor's plan. It details exactly how all the prefabricated parts get put together on site to create the final building. It's all about the building blocks. All right, our fourth and final main view brings the abstract software down to earth, into the real world. This is the physical view. System engineers basically live in this view. It describes the hardware topology, how the software components get mapped onto physical machines, and how all those machines are wired together. This is the site plan for our building. It shows how the whole structure connects to the city's power grid, the water supply, all of it. It's the final link between the design and its actual physical environment. So, we've covered the 4 core architectural blueprints, but that leaves one very, very important question. What's with that mysterious +1? Seriously, what is this extra view that gets its own special place in the name? Why isn't it just the 5-view model? Well, it turns out it plays a really unique and essential role in this whole thing. And here's the big reveal. The +1 is the scenario view, which you might also hear called the use case view. Its whole job is to illustrate and validate the entire design by tying all the other 4 views together. Okay, so this view gets special treatment for a good reason. The scenarios, they define the story. They are the high-level requirements of what the system must actually do. The other 4 views, they're these super technical blueprints explaining how that story is brought to life. So the scenario view acts as the ultimate check, making sure that the final architecture actually delivers on the user's needs. It's absolutely essential to get started, but, and this is the cool part, once the system is built correctly, it almost becomes redundant. The working system is its own proof. Now, this model might sound like a classic, and, well, it is, but its principles are more relevant today than ever. Let's take a look at why this framework has had such incredible lasting power. To really get its impact, think about this. The model was first proposed way back in 1995. That's 2 full years before the first version of UML, the standard modeling language everybody uses today, even appeared. The model's ideas were so solid that when UML finally showed up, it was naturally 4+1 friendly. Its different diagram types map really cleanly onto these 5 perspectives. This quote really just nails it. The primary genius of this model is as a communication tool. It solves that whole elephant in the dark problem we started with by giving each person a clear, relevant picture of the part of the system they actually care about. At the end of the day, the 4+1 model sticks around because it provides a crystal clear separation of concerns. It makes massive systems manageable by letting architects focus on one aspect at a time. It simplifies modeling, it improves organization, and it ensures clear communication, which, let's be honest, is the foundation of any successful project. So here's a thought to leave you with. The next time you open an app on your phone, just pause for a second. Try to imagine the hidden architecture humming away beneath the surface. Can you picture the logical view that defined its features, the development view of all its code, and the physical view of it running on servers somewhere out there? It gives you a whole new appreciation for the silent, structured thinking that makes our entire digital world work. Pretty cool, right?